So the example we left is solve number 1, the absolute value for x minus 5 less than 2. Okay, to solve these things, like I said, I have to put x minus 5 between, this is my c here, between minus 2 and 2. Then this is like simultaneous inequality. By last time we add 5 to the both sides because I need the value for x only. So minus 2 plus 5 is 3, less than x less than 7. And this is my solution for this absolute value. To graph the solution, or to put, first of all, to satisfy this solution as interval, so it's going to be like something like that, open interval from 3 to 7. To graph the solution on the real line, so it will be like something like that. This is my real line. 3 is open circle because it's not equal. 7 is open circle because it's outside the interval. And we draw a line between these 2 points. Okay. So this is a line between the 2 points. And this is my solution for this inequality. Any question for this one? Anyone has a question? Okay, let's do the second example. Number 2, solve the absolute value for 3x plus 2 greater than or equal 4. Who will solve this one? Who will solve this one? By using which property I have to start this one?
The fourth one?
Number 4.
Which property I have? Fourth one, yes. So how can I solve this one? What I have to say? So this is like close to be my C. How? So the fourth property says if the absolute value of x is greater than C, this means x is greater than or equal C, or x is less than or equal the minus C. So you're applying the same property to this absolute value. I get my x, it's similar to this one. 3x plus 2 is greater than or equal, C is 4, or again 3x plus 2 is less than or equal minus 4. This is linear inequality. Why it's linear inequality? Because the exponent for the variable is only 1. And the same things for here. It's a linear inequality. So how can I solve linear inequality? So what I should to do here? How can I solve this linear inequality?
Subtract 2.
subtract 2 from both sides. This is true. So I have to subtract 2 minus 2 minus 2 from both sides. The same things here, minus 2 minus 2. So what I get here, 3x is greater than 2, because 4 minus 2 is 2, or 3x less than or equal minus 4 minus 2 is minus 6. Then what I have to do? What's the next step?
Divide by 3.
How can I get x only, the variable x? How? So by dividing both sides by 3, or I have to multiply both sides by the reciprocal for the 3. So what's the reciprocal for the 3? Is 1 over 3. 1 over 3. Same things here, I have to multiply by 1 over 3, multiply by 1 over 3. So look, here we have to multiply 1 over 3, and 1 over 3 is a positive number. So we don't have to change the sign for the inequality because the number is positive. Okay? So 1 over 3 times 3x is they give me x, because 1 over 3 times 3, they cancel each other, they give me 1, is greater than 2 times 1 over 3, they give me 2 over 3. Or, second one, the same things, x less than or equal minus 6 over 3 is minus 2. So this is my solution for this absolute value. X is greater than 2 over 3, or x less than or equal minus 2. So how can I write this solution as interval notation? So to do these things, I said all the numbers is greater than 2 over 3. This is mean starting from 2 over 3 to infinity. Union, this is mean and here all the numbers is less than minus 2. So this mean from minus 2 to minus infinity, or from minus infinity to minus 2 and 2 over 3 to infinity. Now, how can I graph the solution? Same idea like property number 4. Going back to the property number 4 in the back. So here, two over 3 is here and is close because it's equal here, the equal sign to infinity. This is 2 over 3. Minus 2, this is minus 2 and the close point because it's inside the interval, going to the minus infinity. And here is the 0. It's not inside the solution set. All right, any question for that? Any question for the two examples?
Professor, I'm sorry, I can't really see the graph, the line graph that you did. Oh, I see it now. Oh, okay, it's 2 and 2 over 3, the points, correct?
A minus 2 here.
Okay.
Yeah, 2. Yes. Minus 2, and here 2 over 3.
Thank you.
No problem. Okay, so this section is finished, 1.7. Now let's go to the new section, is 2.2, is functions. So 2.1 function. So first of all, let me explain what is the function. So function in general, if I need to apply it in our real life, it's like a machine. It's a machine, look like this. This machine is called function. I call it by letter F, or any letter you want, H, G, whatever you want. This function has to put, it has input, and they give me only one output. The input is called as a variable x. The output is called as f of x. So again, this is x here, input. They give me one output, f of x. So for each input has only one output. For each input has only one output. This is the important rule for the function. So here I can set it as a machine. So I can define it as a function f, called as f, or any letter you want. F is a rule that assign to each element x in a set A exactly one element in a set B called f of x. So what is A here and what is B? What is A? What is the set A and what is the set B? Who will give me what is the set A and what is the set B? So the hello. Okay. So So I gave the definition for the function. So I said the function f is a rule that connecting or assign to each element x, I set a exactly one element in a set b called f of x. So what does that mean? Like every element in the set A has exactly one element in the set B. So again, if I have the function as a machine, like I said before, so f here, this is my function f. It has input and it has output. The input is x, the output is f of x. So for each input, the x has only one output. That's mean this is here my machine. So again, the set A here is mean the domain set. So this is my domain set here. And the set B is called the range set. So what is A and what is B? So what is A and what is B? So A, the set that the X come from the set A. So this is belong to the A here. This is belong to the B. So A is the set of the domain. Is the set of the domain. And B here, it's f of x coming from B, the set B. So B is the range. Is the set of range. So this is domain here. Here's the range. X comes from the domain set. F of x comes from the range set. Okay? What is the domain from the last classes? Anyone can remind me what is the meaning of domain? What is the domain set?
That's an X.
It's X, but what is the meaning of domain? Like I gave the definition from previous classes, if you remember. Domain set. Did you remember when I said domain is a set of all possible input? Like wherever I can put it here inside the machine is called the domain. So let me remind you the domain, because now the domain here is a set of all possible input. So all the possible inputs that make the function f define is called the domain set. Okay, So here's domain set. Okay. Any question for the domain? The range is the possible output. The output from the set. When I plug any element from the domain, they give me output. The output set is called range. Okay. So another way for like to picture a function is called a row diagram. So another way to picture a function f is by using a row diagram. What does that mean? So let me explain it by picture. So if I have two sets, this is the first set here, and this is my second set. This set is called A, and this set is called B. This set has element 1, 2, 3, 4, for example. This one here, 2, 3, 4. And this set has 3 elements, for example, 30, 70, 80. So this is like a row diagram. This is mean to make this as a function, like I make every single element in the set A has to go to exactly one element inside the set B. For example, if the one goes to 80, and the one cannot go to another element in the set B. For example, 2 goes to 30. 3, for example, goes to again 30. 4 goes to 70. So look here, every element in the set A goes to one element in the set B. The 1 goes to 80, 2 goes to 30, 3 goes to 30, 4 goes to 70. So this is...
Can you go to the last page for 1 second so I can take a picture?
Yeah, sure. By the way, all these lectures I posted on Blackboard. Like if you lose any slides from previous classes, I post the link for all these lectures on the Blackboard. Okay, so this here diagram, it is a function diagram. Why? Because every element in the set A takes only one element inside the set B. But these things here, if I have set look like this, this is my set A, here's my set B, 1, 2, 3, 4, 1, 2, 3, 4, 1, 30, 70, 80, 30, 70, here's 80. So look to this diagram. If the 1 goes to 80, okay, if the 1 goes to 80, and in the same times the 1 goes to 30, 2 goes to 70, 3 goes to 80, 4 goes to 30. We have to check, is every element in the set A goes to one element inside the set B? So if we look into the 1 takes 30 and the 1 takes 80 in the same time, and this is not true because the one element here, the element number 1, takes 2 elements inside the number B. This means, but about the other elements, 2 takes 1 element, 3 takes 1 element, 4 takes 1 element, but because the 1 here takes 2 elements, 30 and 80, this means this diagram is not satisfied to be a graph of function. Okay, so here every input has only one output, so it is a function. Here the element 1, the element 1 takes two elements on set B. 1 goes to 30 and the 1 goes to 80. So it is not a function diagram. Okay, makes sense? Anyone has a question? Okay, so this diagram is not a function. This diagram is a function. Now let's go to function, evaluate the values in function. I will do that by example. So example, suppose my function look like this, a function f is defined as f of x equal x squared plus 4. First question, evaluate f of 3, comma, f of minus 2, and f of square root of 5. Second things, find the domain and the range of the function f. 3, draw a machine diagram. For the function f. Who will start solving this question? Who will do the first one? You evaluate f of 3, f of minus 2, and f of square root of 5. To do this, you have to plug the 3 inside the function and you get the answer. F of 3 means you have to plug, let me do the first one and I will let you do the second one and third one. So the first one means f of 3, I have to plug the 3 inside the function, this my function. When I plug the 3 inside the function means I have to put the 3 inside the variable x. So 3 square plus 4, this mean equal 3 square is 9 plus 4, and the answer they gave me 13. So f of 3 is 13. Who will do the second one and third one?
-2 squared plus 4 equals 8.
Exactly. So -2 square plus 4. This is equal 8. Why? Because -2 square is 4 plus 4, and 4 plus 4 is 8. Who will do the last one?
Square root of 5 plus 4 is the square root of 5 squared plus 4, which is also just 5 plus 4.
5 plus 4, yes. Square root of 5, everything square is inside under the radicals is 5, because the under the radicals is already positive, so we keep it positive. But if it's not positive, for example, it has to be the absolute value for inside the radicals. But most of the time must be under the radical positive, because here we have even number. So it's 5 plus 4, and plus 5 plus 4 is 9. Any question? Okay, for the second one, find the domain and the range. Again, what is the domain? We go back to the first slide. The domain set is a set of all possible inputs. So what I can plug inside this function, and they keep the function defined. What is the value if I plug it inside this function that's keep a function will define? What is the value? Or I can think in different way. If I plug the positive numbers here, is the function will still define? Like if I plug 1 inside the function, still the function define? They give me answer, I mean, in other words. Define means they give me an answer or output. If I plug the 1 here, yes, still define. The 2, yes. 3, they give me answer, no problem, no issues. 4, 5, 6 to infinity, still they give me an answer. So no issues if I plug any positive input numbers. What about the 0 here? If I plug the 0, if I plug the 0 inside this function, will still define? They give me answer. Yes, if I plug the 0, f of 0, they give me 0 square plus 4. 0 square is 0 plus 4 is 4. So still define. So f of 0 is well defined. What about the negative numbers? Can I plug negative numbers inside this function?
Yes.
Yes, if I plug any negative number, -1 for example, -1 squared is 1 plus 4, it's 5. -2, same things. I can get answer, -3. So I mean, like I can plug all the positive numbers. I can plug 0, 2. I can plug negative numbers. This means the domain is everything. I mean, for everything, all real numbers. So the domain is all real numbers. If I plug anything, still I can get output. This means the function would be defined. What is the range? What's the output after I plug all real numbers? What is the output for plugging the real numbers? Any idea what is the output? Or what is the range for the function f? Okay, let me simplify it more. So if I want to plug, for example, 0, what does the 0 give me after I plug the 0 inside the function? F of 0 is 0 plus 4, and this is 4. So when I plug the 0, they give me 4, right?
Would the range be like greater than 4 or something?
Yes, this is true. But how you think for that? I'll explain. So I'll explain how he think, how is the range, it will be greater than 4. When I plug the 0 inside the function, they give me 4. Why? Because f of 0 is equal 0 squared 0 plus 4 is 4. When I plug positive numbers like 1, for example, f of 1, they give me 1 squared is 1 plus 4 is 5. Plug 2, they give me 2 squared is 4 plus 4, they give me 8. So the number is increasing, 4, 5, 8, and they goes to infinity. It goes to infinity, is increasing. The answer, look to the output, 4. The output is 5. The output is 8. And if I want to plug 1.5, for example, inside the function, they give me another number between 5 and 8. So I mean, like all inputs look 4, 5, 8 to infinity. What about if I plug negative numbers, for example, -1 inside the function? -1 squared is 1 plus 4 is 5. 5. And -2, if I plug them -2, the same things, they give me 8. This is mean all the output starting from 4 and going to infinity, 4, 5, 8, etc. to infinity. The same things if I plug negative numbers. -1 goes to 5, they give me 5. -2, they give me 8. -3, the same things like 3. So this is mean the output, it will be start from the 4 until infinity. And this is my range. So the range is from the 4. The 4 is including closed interval 4 to infinity. The domain here is the real numbers, R. Any question how you think about the domain and the range? Do you have question? So just you have to try the numbers, what is can I plug inside the function, and you have to check what's the number they give me out as The out is range, the in is domain. Third question, draw a machine diagram for f, for the function f. So to draw a diagram, we have to draw something like that. It's a machine, the function f has input x, has output f of x. So the last three, third one, let's look like this, machine. So this is my function f. Here is x input. And write down here the real numbers. Here is output, f of x is the set from 4 to infinity. Is it clear? Any question for the third one? Okay. Another example. So the example is, let my function f of x equal 3x squared plus 5 plus x minus 5. The question is, evaluate first part of the question. Evaluate f of minus 2, f of 0, f of 4. Second part, find the domain. Who will start for f of minus 2? What is f of minus 2? What's f of minus 2?
3 times -2 squared plus -2 minus 5.
Yes, nice. So 3 times -2 squared plus -2 minus 5. 3 times -2 squared is 4 plus, but we have here minus 2. So minus 2 minus 5. 3 times 4 is 12. Minus 2 minus 5 is minus 7. 12 minus 5 is minus 12 minus 5 is 5, positive. Now f of 0. Same idea exactly. You plug the 0 inside the function. How will do it? You plug the 0 inside the function. So they give me 3 times 0 square plus 0 minus 5. 3 times 0 square. 0 square is 0. 3 times 0 is 0. Plus 0
-2.
minus 5. What is the answer? -2. I get a question here. You could not multiply -2 and -5. Where exactly -2 and -5? Here?
Oh, that was my fault.
Okay, so here for the first one, -2 square, we distribute the square for the negative and we distribute the square for the 2. The minus here square is give me 1, and the 2 square they give me 4. So here, because we have parentheses, everything square they give me inside 4. Let me remind you, -2 square they give me -4, but -2 everything square you give me 4. This is a question in Weber sign from previous classes. Okay, same things here. Now f of 0 they give me 3 times 0 square plus 0 minus 5. 0 square is 0, 3 times 0 is 0, plus 0 minus 5, they give me -5. Third one, f of 4. Plug the 4 inside the function. What I get? 3 times 4 square plus 4 minus 5. So 4 square is 16. 4
48.
times 4.
3
48?
times 3 times 16 is 48.
Yeah, 16 times 3 is 48. Yeah, 48. Plus 4 minus 5. Plus 4 minus 5, they give me a -1. Give me -1. 48 minus 1 is 47. Any question? Okay. Find the domain. Second part. What is the domain? Can I plug in positive numbers inside this function? For example, 1. If I plug the 1, yeah, they give me answer. 2. 3 times 2 square plus 2. Yes, they give me answer. 3. Yes. 0. Can I plug the 0? Yes, I plug the 0 here already. F of 0. If I plug negative numbers, they give me answer. Yes, look, f of -2, they give me answer. And the same things for f of -1. Same things for any negative number. So this is meaning I can plug any real number inside this function. So the domain is the real number, is all real numbers. R. Any question? Okay. Now let's go to another topic inside this section is the piecewise function. Piecewise function is a function with 2 parts. piecewise function. So I'll explain that by example. So if I have a function c of x, this function has two parts, but with different domain. 39 and 39 plus 15 times x minus 2. Here 39 for the domain x between 0 and 2. This is the only domain for the function c of x equal 39. For the second function has a different domain. Here is f. The domain for the second function if x is greater than 2. For any number is greater than 2, like for example 3, 2.5, 3, 4, 5, 6, whatever, we have to use this function. For the domain between 0 and 2, we have to use this function, first part in the function. So my question is find c of 1 over 2 or 1/2. Second one is c of 2. Third question is c of 4. We'll do the first one. Okay, let me do the first one and I will give you to do the second one and third one. C1/2, I have to check where is x available, in the first domain or in the second domain.
First,
So I have to check where is 1 over 2 is available, in the first or in the second domain. Is 1 over 2 here or is here? Yes, Mobin?
First.
Okay, first one. So 1 over 2 is between 0 and 2. This means I have to use the first function. So c of 1 over 2 or 1/2 is 39. Now for the second one, c of 2. So you have to check where is 2, in the first domain or in the second domain.
First.
First one. Why? Because here x between 0 and 2, and 2 it's inside the first domain, because the interval here is from 0 to 2 and the 2 is inside the domain, here from 2 to infinity. So first domain says c of 2 is 39. Third one, c of 4. Yes, it's in the second one. Why? Because 4 is greater than 2. So I have to plug the 4 inside the second function. So they give me 39 plus 15 times 4 minus 2. Give me 39 plus 15 times 4 minus 2 is 2. 39 plus 30. Give me 69. Any question? Any question for the piecewise function? Okay. So now let's go to the net change of the function. Okay, net change of function. Net change. So the net change, let me give you the formula for the net change. So the net change of the function f of input change from A to the point B is given as f of B minus f of A. So this is the formula. So the net change equal f of B minus f of A. So if I give you 2 points and I give you a function, and this function, the input changing from the first point to the second point, and I ask what's the net change using this formula, f of the second point minus the f of the first point. Okay, example. Find the net change of the function 1 from 1 to 3, second one from -2 to 2. Who will do the first one? By plugging inside the formula here. Here's the formula.
One
Yes.
minus 3.
Yes, 3 f of 3 minus f of 1, right? The first one.
Mm-hmm.
So what is f of 3? What is the answer for f of 3? Plug the 3 inside the function. Oh, I did not give you the find the net change of the function. Hold on, sorry. Of the function here. The function is given as f of x equal x squared. So this is my function. Change from 1 to 3. So what's f of 3? Plug inside the function, f of 3 is equal 3 squared. What is 3 squared? Minus inside the function 1 squared. 3 squared is 9. Minus 1 squared is 1. The answer is 8. For the second one, what is the net change? By using the formula here. So the net change is f of 2 by using the formula. This is my B here, and this is my A. So f of 2 minus f of A is -2. Plug inside the formula, f of 2 is 2 squared minus -2 squared. 2 squared is 4 minus -2, everything squared is 4 again. 4 minus 4 is 0. So the net change for the second one is 0. Any question? Okay. Last example before we end the lecture for today. Example is evaluate a function. It's given as f of x equal 2x squared plus 3x minus 1. First part is f of a. Second part is f of minus b. C is f of a plus b, and D is f of a minus h plus h minus f of a over h. And here h is not equal 0. So we're going to do the first one, and we will left wherever we can. We left it for the next class. First one, who will do the first one? F of a. Just plug the a inside the function. Where's f of a? You plug the a inside the function. Here, instead of using numbers, we're going to use letters. The same idea like before, but here we use letters. So where is f of a? Plug inside the function. F of a give me as 2. Yes, who will do it?
2a squared
Okay,
plus 3a minus 1.
minus what?
1.
1. Okay, nice. Thank you. So now 2 times a squared is 2a squared plus 3 times a parentheses, we give me 3a minus 1. We cannot simplify it more. So f of a is 2a squared plus 3a minus 1. Same thing for the b. F of minus b. Plug it inside the function here. Give me 2 times minus b squared plus 3 times minus b minus 1. We simplify it. Minus b squared, they give me b squared. 2, because we distribute the square to the minus and the 2 the square to the b. They give me b squared. Plus, here we have, before we put the plus, 3 times negative b. 3 times negative b, they give me negative 3b. And minus 1. We cannot simplify it more, this one. So we keep it like this. For the third one, is need more time. And the fourth one will need more time. So we're going to do the third one and the fourth one next time, next class. We end until here today. Any questions so far?
Do you have homework?
homework, yes, I will post the first. I will post homework for 1.7, and maybe I will post the homework for this one too, because we already like almost we finished this one. Okay. So I'll stop until here today. Thanks.
Thank you.
You're welcome.